Okay, so can you hear me all the way? Yeah? Right, so what we're going to talk about now is data. We've been looking a bit into models yesterday. And if you use models or if you use any tool in water resource management, you of course always need data. And as we've discussed before, that is often actually the main problem. Because data is, there's not enough data to really describe the catchment areas and the flow. And once you get data, the quality is often not very good. You've already registered this one, which is also a little bit about data, this flood and drought portal, but that we'll look into tomorrow. Today is the basic data that we're using. You have rain gauges, you have pan evaporometers, temperature and so on, water levels often with a gauge like that, rating curves based on measurements of discharge and water level at the same place. And in some places you might have structures that can actually measure the discharge, or where there's a fixed relation between the water level and the flow. But poor data is a big problem, and when you have poor data, you get poor results of your study, and the decisions that are taken on that basis are then also poor. Back in the 80s, the World Bank had been financing big irrigation schemes here in India for quite some time, and they saw that many of these were actually poorly designed. They turned out to be too large. The water was simply not there, or there were other issues with the design, because they had been designed on the basis of available data, and that data was wrong. So the World Bank was twisting the arm of India, you might say, and saying, you can now borrow money for hydrology project 1, which will improve the data, but you cannot borrow for anything else. So what would you like to borrow money for? Right? And I was actually on 2 missions back in 93 and 94, I think it was, with the World Bank to find out what is the actual conditions on data in the states that would participate, and what should be done about it in terms of equipment, in terms of methods of data collection, data processing, and so on, training and all these things. Right? I remember we visited AP in those times, the state of AP, to see what conditions were there. And as part of that visit, they had arranged a study tour for the World Bank team to see a few of the stations. We were gone for 2 days, but there were only 2 flow stations on the schedule, which I thought was a bit slow. So I asked them, can I see a map of the stations and the route we're taking? And I could see that on the way we would actually be passing 3 or 4 other stations. So I asked, well, why don't we see this one? Well, the road is not so good and your shoes will get muddy. And they had an excuse for all the other stations than the 2 they wanted to show us. Well, okay. So we went to the first one, and this was a station where they actually don't measure the discharge. They measure the water level at 3 locations about 100 meters apart. And then the idea is that if you have a slope from these 3, you can see the river is sloping. You know the cross section, then you can then calculate the discharge, right? So not super perfect, but still would give some idea. So of course people were there from the government, but including the local man who was actually taking the measurements. So that's where everything starts. So I called him over and asked him, what did you measure today? Right? And he opened the register, and he had his water level at this particular gate, and we went down and checked. There was basically no water. And that's also what he recorded. So I said, when was the last time you actually recorded higher values here? And he said, no, that's 4 years ago. He said, 4 years? Yeah, that was before they constructed the dam, he said. So it turned out that just upstream was a dam that hadn't spilled for 4 years. And he's been measuring 0 for 4 years, and nobody has discovered that this station was absolutely useless. Right? So that was a bit of a pity, but anyway, we went to it was very nice, grass was cut and everything was painted. We went to the next one where at least water was flowing. It was about 20 meters wide or so. this was just by the road, so that was easy accessible. Everything looking very nice. Again, I called the local man and what he had measured, and he said, well, the water level is 0 and the discharge is 0, because he had a rating table in his form. But we could see it moving, and it was 20 meters wide, and they even sent a man across to get an idea of the depths. And at one point he was into here, but otherwise to the waist or so. So obviously this was flowing. So something was wrong. But then looking down the road, we could see local people had stopped, and they were in the river taking sand, and just taking sand out of the river. This was sand mining for construction, most likely, right? So this gating site was located at a place where the cross-section would be changing by the day, right? And having a fixed rating curve was definitely not good. And the only real solution was to move the station so far away from this, upstream this site basically, right? A place where it's not influenced by sand mining, or stop the sand mining and then wait until you had a stable section. So, and these was unfortunately the only 2 stations they had chosen to show us. So that illustrated that AP and many other states also really had a need at those days to improve data collection. Which has then also happened, right? Because the main purpose of HP1 was then to do that, get better equipment, get procedures to be followed. How do you collect the data? How do you check the data? How do you enter it in databases and all these things, right? It's not perfect, but working later on with some of these states, at least data quality had improved quite a lot. There was one in Indonesia. I'll also just tell you about. This is also back in the 80s actually. Let me make this a bit larger. So here they were. I just typed this in, but this is how the form looked. In Indonesia, they have local people hired to go and measure the water level in the river. And in those days, at least in these rivers, these local people would measure 3 times a day. Pagi jam means morning time in Malay, and siang jam and sore jam is then midday and then afternoon. And rata is the average, right? So they would get the water level 3 times a day, send that in, and then at the organization they calculate the average and store that, right? And at this particular station, data was looking like this. So typically in this morning value, 6, 7 most of the time, and also in the afternoon, it was late afternoon here, it was also 6, 7. But the one in the middle here, the one around noon, 12, and then it was 1, and then it was 12, and like that, right? So the average came out like 5 or 8 or 9 or something. But all the values were like this, right? How could that be? This was up a river somewhere. There's no tidal effect or anything like that. What could possibly explain that you have 6, 7 in the morning, and again in late afternoon you have 6, 7, but 1 or 12 in the middle of the day? How is that possible? Not possible. But this was months after months was like this, right? Can anybody figure out what the problem was? One of the problems was actually that this particularly man for this village, he was actually able to read, but he hadn't quite understood what he was supposed to do. He could read what is set up here, right? Where it says morning time, noon time.
He's putting in the time.
He's putting in the time. Morning time, okay, 6 o'clock, 7 o'clock, sometimes 12 or 1 o'clock, you know, and then again 6, 7 in the afternoon, yeah. He put in the time. He had these people from the big town had come and told him, "Can you fill this out?" You know. So you know.
That I was thinking that these are the
Yes, it was.
12.
And okay, this local man, you know, they hadn't explained what to do. He hadn't understood, so he reads, okay, and he puts it in. But the organization responsible for the water resources data, what do? They calculate the average time a day and store that as the data that we are supposed to use to study their, you know. I mean, they had another interesting one was one of these rating curves where Yeah, so if you have a good rating curve, it looks something like this, right? That you're measuring, the points you have measured are more or less on the line. This is actually a very nice one. There are some organizations around the world who make a new rating curve every year, sorry. They have, each year they have, this is the rating curve of this year, which is good in the sense that it recognizes that rating curves change as they do, but they don't change on the 1st of January necessarily. They change typically when you have a big flow event passing through, because that might change the cross-section and then the relation is different, right? So it's actually better to assume that it doesn't change until you actually see the change occurring, and then from that date on you then have a new one. But there was one in East Indonesia where the points, there were some points following more or less a curve like this, but then there were also points following a curve about a meter higher. So the first rating curve we just made automatically in the middle, but we were checking that because we were also using models at those time. And if you took the rainfall and potential evaporation and tried to calibrate a model against discharge calculating using a rating curve in the middle, it just didn't match. So we went back and looked at the rainfall data and so on, but then looking at the rating curve, we saw that it actually looked like there were two rating curves, one here and then one somewhere a meter higher. So one explanation could of course be there had been a flood change in the cross section and then it was different. But if you looked at the timing, it would switch between the one and the other. So it was sometimes one wouldn't match and sometimes the other would match. So for a long time we couldn't quite figure out what the problem was. But then I remembered from the field trip, I've been around to see some of these stations, that often the staff gauge that measures the water level hadn't been painted for a long time. And the way they measure discharge is that they send a team around. It goes from one station to the next, and then it measures the discharge, and then it looks at the staff gauge, what's the level. So they don't know the gauge. The local reader would know it because it comes every day. And you can't see below the water because it's brown like it is in most parts of the world. So you can only see the number above, and typically the water level here in this station was somewhere between 1.5 and then 3.5 meters. So most values were 2 or 3. And 2 is written like this, right? And 3 is written like this. So if you only have the top of the numbers, you can't really tell what is what, right? If the rest is sort of faded away. So the guess was that either many of these 2 values should have been 3 or the 3 values should have been 2. So we just tried to change it, and so we had got one curve matching very nicely here, or another one matching there, and one of them gave hopeless result, but the other one matched very nicely. So we decided that's the issue, right? But like that, you can spend months, of getting any sense out of the data. And yeah. And so, no, I think that comes in a minute. Let me get back to Scandinavia in a while. Just a few examples here. These are from some stations in Africa. So this is discharge measurements or discharge data. There's a period here from 84 to about 90 where you're getting some very flashy peaks. In the low flow, it looks a little strange that you have some flow sometime and then absolutely nothing suddenly. And here 1 year it goes down where it looks a bit like base flow, but generally the low flow looks a bit strange. Peaks might be fine. I mean, if this is a small flashy catchment, it often looks like that. But this over here, I mean, this is not possible, right? Here it goes up and stays here for a while and then down again. Here particularly, being up here and doing like this, all of this is obviously wrong, right? Something similar here. This looks rather natural. This must be wrong, this must be wrong, this must be wrong, like that. And whether this is actually wrong or right, you don't really know. You will still doubt it, right? But the problem with, the only thing you can do here is throw this away, and maybe also some of this. But whenever you do that, you're losing data also, right? The amount of data you have to actually work with gets less and less. Here again, this might be right, but not both of them. Right? So what are the consequences of wrong data? Well, this is a Teton Dam in the US, and this is what happened in 1976, that it failed. Whether this was wrong data, I don't know. But if you use that data as a basis for design, things may go very wrong. Of course, if you know that your data is something like this, then you will be very careful in your conclusions. You will still, let's say we're designing the spillway of a dam like that, right? So you will do your analysis, you will come to some conclusion and say, okay, we believe that the 100-year flood is 1,000 cubic meter per second, but the data is so uncertain, so we recommend that you design it for 2,000. That's going to cost 2 or 3 times as much, right? So the dam owner will not be pleased with, and the organization will be sad that they didn't start proper data collection 10 years ago, right? Because then they could have saved a lot of money. Yeah, let me just, so that not everything is from Asia. In Denmark, we have rainfall being collected also by local people. It may have stopped now. I think most stations are now automatic. But at least some years back, rainfall was collected just by open. I can't draw in this way. No. So you ask people to have a rain gauge and measure. And there was then one location where this rain gauge was in the middle of the garden. So there's a house and a fenced-in garden, and the rain gauge was there. And that has measured for a long time. Then suddenly the organization, the Danish Meteorological Institute, they noticed that the rainfall at that particular rain gauge is now starting to be smaller than the other rain gauges in that area. If you make a double mass curve, maybe you know that, if you accumulate the rainfall on one station, and then the average rainfall is several other stations, and then when you make a plot, you get more or less a straight line. What happened is that straight line suddenly changed its slope, so it was like this, right? And at that time it changed. So they checked where is this rain gauge located, and then they could see in their records it changed just after that house was sold, and another person moved in and took over the monitoring, right? So something happened, right? This guy has done something. So they called him first and said, are you measuring? Yes, I've been measuring every day, and so on. We'll just come and have a look, right? So they came to see him, and what has happened was that he had, in the beginning, he had been out there at 8 o'clock every morning sharp to measure the rainfall. But at 8 o'clock, it may be snowing, or it may be raining, or very windy, or whatever, and maybe he just got out of bed, I don't know. So he didn't really like to go out in the garden at that time. So he moved the rain gauge so he could reach it from the window. And that means his roof was partly hanging over the rain gauge, but only partly. So if it rained from the right direction, it would still be into the rain gauge, right? Yeah. And in Norway, there was a family that was measuring the water level in a river in their backyard, basically. And that water level was varying quite slowly like this. But then suddenly in August, they went like that for 3 weeks, and then they went back to doing like this, right? So again, they visited that family and said, what happened? We've been measuring all the time, but in August, we were at our summer area further up the same river. So we just measured up there. It's the same river, right? So what's the problem? So there's a lot of stories like that around the world, which also emphasizes you need to check the data at all times, right? And make quite a detailed analysis of the look for errors. Assume that there is something wrong in this, right? And you can, of course, analyze the data separately, or you can sometimes combine it. If you look at the catchment, the amount of rainfall over the catchment minus what evaporates should be the flow. So just by taking the data directly and accumulate it for some time, you can see, does this look reasonable? Right. So you can also combine them. Right. But as we said, as you eliminate errors and take away also dubious errors, you get higher accuracy in your data, but you also get less data available. Right? And this again also means that whenever you're working with this, when you're doing whatever study you're doing, you need to assess what is the impact on my results of this limitation in my data. So how uncertain are the conclusions that you're actually drawing? And that's a difficult task, right? I mean, you're hopefully rid of the obviously wrong data, but many errors can't be detected, right? Rating curves can be very uncertain. There was another example, and I'm not allowed to tell you where it was in the world because there was a court case where we were witnessing basically, but the runoff from that area was part of the analysis, and when we worked on that, there were very few rating curves, and most of them were completely useless. But there was one that looked reasonable, so we based basically all analysis on this one. But when we started using it the first time, even that one we thought wasn't quite good enough. So we asked to get the measurements for the rating curve, and they gave us that. And then we made another rating curve, and with that we got results that looked much more reliable. And since this had a lot of political attention, we thought we better explain exactly what we've done to this rating curve. So we wrote a long explanation about that. That might have been a mistake because that actually indicated that authority didn't really know how to monitor rainfall or monitor discharge, right? So they were complaining for a long time about this. And at the end, we actually went back and said, well, if we don't change the discharge and we use it as it is originally, the impact on the overall conclusions of the whole study, which was also a marine thing, was very, very small, so it didn't really matter. And then they stopped complaining. But it became a bit political. I'm sure we were right, but they didn't want to lose face and admit that the only rating curve that might have been okay even wasn't. Right, so yeah, but assessing what do these data uncertainties mean for your conclusions? I mean, sometimes you might be lucky that the conclusions will hold anyway, right? If the question is, will the flow ever get higher than something? Then within your central estimate is maybe here, but your maximum is here, and if that something is even higher, then fine, right? But often you're not that lucky, right? So often you end up saying, I think it'll be like this, but there is still a risk it'll be like that. And it's very difficult to quantify. Sometimes what you can do is that if you can quantify your uncertainty in the input data, and then change your input data to the high and low boundaries of your uncertainty, and then run that through the whole analysis, then you also get your interval of uncertainty in the results, right? But even that, I mean, when you have discharge, this discharge, how accurate is that? It's very difficult to say, right? So it's a difficult task. Typically also in reports like this, you would recommend ways of reducing the uncertainty. At DHI, we have made a lot of flood forecasting systems around the world. And unfortunately, very often once a country or an organization decide, now we want a flood forecasting system, they start two projects in parallel. One is to get the actual models calibrated and set up and running and system. And the other is then the network of data that will run the forecast. Because now you need real-time rainfall and real-time water level and discharge and so on. But as they start that in parallel, it means that the data that will drive the models in the forecasting system is not available yet. Some are new stations, some are maybe existing stations, but you only have daily data, and once you have the network up and running, you get values every 10 minutes or hourly, whatever. So you finish calibrating the model using whatever is there of daily data and old data, but then run it with something else. And there's no guarantee that you'll get the same results. So typically we at least recommend at the end of that let us come back in 3-4 years, or let's follow this for that period, and then see as data comes in from the real network, we can then adjust calibrations and so on. this is how data was 30, 40 years ago, and unfortunately there are still places where it looks like that, but luckily it's now improving, right? So you're getting systems where data is working well. We've been setting up some databases from different areas. Normally what we do at DHI mostly is the modeling studies and decision support and so on. But for some areas, they say, give us just a system where we can keep our data, water resources information, and where we can share it also. And this happened for Lake Victoria, where you have these 5 countries around that same lake. They wanted to monitor the conditions both in the catchments that run into the lake and then the lake itself, water quality, water levels, flow, rainfall, all these different things. Right? So we made a system that is using GIS. So you have maps, and you can go background maps and so on, but where you have all your monitoring points, and then link these points to time series so you can plot variations and you can make different statistics and so on. The same for the Zambezi River, which is also in Africa, where you have some large reservoirs, and Lake Malawi is part of that also. So again, I think maybe 9 countries cooperating on this. It's happening more and more around the world that countries are actually accepting to share the data. It may also happen in India. I think it is happening in India now with India RIS and other organizations, right? But it's been quite a struggle to get to that point.
But India and Pakistan sharing data is far from
Yes.
happening.
We have.
Because in Central Water Commission has a project
Yeah.
on Indus,
Yes.
where people visit from this part to Pakistan,
Yeah.
but the data sharing is
No, and
not
that
happening.
it's not likely to happen anytime soon. No.
Yes.
But even in Europe, to my big surprise, I've been working in Belgium, which is a country that was invented, I think, by Napoleon in 1800 something, after some war between France and the Netherlands, who were sharing a border. He decided that we will now create a country which takes part of the northern France and part of southern Netherlands, but it's one country called Belgium, and here is a king. And then that is a buffer zone between France and Netherlands, so we don't fight anymore. That might be a solution for. No. But Belgium, in South Belgium, they still speak French. In Northern Belgium, they still speak Flemish, and these people don't cooperate. I mean, this has been one country for more than 200 years. They share the king and they share the capital, where it's a mixture of people. So. I think based on that, they don't want to separate. But when we work with the French people, and it's a river that meanders into the Flemish, we can't get any data from the other side of the border. And this is the same country. And in Europe, I mean, in EU. Anyway. But getting back to this data system, in order to provide these database systems for these countries and other organizations, we've developed what's called MyInfo, which is then have data on the desktop that you can see like this. So you have maps and you have your stations, and you can access these directly. There's a web version, so you can on the web you can publish exactly the same thing, or you can choose that only part of the data is available publicly. You can also put passwords on the web if required, but the basic idea is that let anybody who's interested go and see what are conditions, how much has it been raining here, what is the water level in the reservoirs, and these kind of things. So it's, you have the desktop and the web and the database. And under this is something we call my workbench, which is a bit like the engine. So all the actual tools for analysis are in there. All the tools for making GIS maps, and you can even do some scripting, and you can. There's a spreadsheet functionality that's a bit like Excel, so you can pull your data into that and work there if you like, and so on. And we're going to use that later on today. What time are we stopping today for lunch? normally 1:30? 1:30. So we have this where typically the desktop is then used by the main organization and the main users. And that's where you're setting the whole thing up. And if you're just working individually, that's the one you're working for. Or you can go directly into the workbench, as we'll see. So the web is then, actually what they say here, out-of-the-box web client. I think once you've set this up in the main system, you can more or less push a button and then it generates the websites, more or less. But the workbench is the one that I'm planning that we should use. And we had some issues installing it. Professor Sharif was doing that earlier. And it turned out that actually the new version, I'm not into this software, DHI, other people do that. The new version doesn't run on 32-bit machines, apparently. But somebody just came over from the DHI India office and fixed it in the sense that what they have now provided is a version from 2016. And then what they did is that they have given me a version which is without any license. It's a bit limited. Normally we use for the database, we use something called PostgreSQL, which is a quite large, a bit like Oracle database system. This one uses an SQLite, which is smaller, but still workable, right? And it's an individual license, so you can't have it on a server and share it. You have it on separate computers like that. But the good thing about it, if any of you are interested, is you can keep this and install it on your own computer and whatever if you want to use it later on. It's tools. I can make a demonstration in a while, but it's tools that combine this GIS layers and the time series and enables different kind of checking of at least to find some of these obvious errors that you often find in data and comparing data in different ways. So that will work with in the afternoon. And here it says a demo, so I will make a little demonstration of that. And the one I have installed is with a license, so I'll just find my dongle for that, if I can. There we go. Since we're changing the software, it means that we will also, I'll have to rearrange a little bit the input, because what I had done for that exercise was to make a backup of a database from my system. But now it's a different kind of database, so, but we'll figure it out. Okay, so let me just start this one. And like I said, this is the engine, so at DHI, well, I always use this. MyInfo is a more user-friendly top of it, but it's also limited. Here you have access to all the tools. In MyInfo, it's only set up for selected tools. So I think I'll select this database here. So now I'm logging into a specific database. I had 4 or 5 on my computer from different projects that we're working on. This one is one in Africa, in Lake Malawi, and it would be good if I can be on the internet. So let's see if that is possible. And we'll just have to do like this. So now I should be on the internet. Here is normally a web page. We'll see if it comes in a minute. But generally, when you work with this, you have this central area where you're basically seeing whatever analysis you're doing, and then there are explorers over here. Right now, what is open is a GIS Explorer, and I can take a layer. Let's take some catchments here, for example, and add to a new map. And then it makes a map here with those catchments. And if I'm on the internet now, I can put in a background map of that layer. So this is now Malawi. All these are catchments. Let me add the river and maybe some stations like we have. These are gating stations on the river. Normally I normally make them a triangle instead of a circle. I don't really know why, but I like to see them as purple triangles, so I change the color, purple. And so these are all sub-captions that we're working with. You can make them a bit transparent if you want to see what's in the background of layers, and you can then zoom in with the mouse to different areas like that. Let me add the rainfall stations as well here. And of course you can label stations if you want to know what they're exactly where they are, so put the name on here. All this you'll be exercising, so you don't have to take, but generally work with GIS a bit like so many other GIS systems, right? You cannot do everything, but you can still with layers, you can, I think, merge layers and I mean, do some basic GIS management. If you want to do more, QGIS or ArcView or whatever you have is an option, right? But basic stuff, and you can import shape files and so on, which you will be trying, because what I'll do for that exercise is I'll make some shape files and other things from this that we will then import as part of the exercise. So then this way you know where you have your data, and then time series are also there. Discharge time series, for example, which you can put in a new chart, so we have a graph of the discharge. Here again, probably some data with a problem. Zooming, you just make a square like this with keeping the mouse down, and when you let go, it's zoomed both in both axes at the same time. And it looks like here there might be a data issue in this particular one. We found that, I think, with many of these, but we'll also do that as look into that as part of the exercises. So generally, whenever you click on anything, if I click on a discharge time series here, this window over here is changing. This is properties of that particular series. This is the name. It is cubic meter per second. It's discharge. Its first time step was in 1945, and the last is like this. And so different basic information about that particular series. So if I take a rainfall series instead, like here, click on that, well then we have on that rainfall series. This window is then the tools available for whatever you have selected. So if I select, like here, a time series of discharge, well then here are the tools I can use. Let's take maybe this one, let's just see what it looks like. If I plot this, yeah, this is then discharge from 1950 to 2000. What do you think of this discharge series? Does it look like does it look natural? No? Any problem in that?
In the year between 1956.
I'll just,
Very
yeah. There's something is strange, right?
there has to be
Probably this and that is correct. Maybe also this period here, but this here in the middle is very strange, right? One of the tools that I often use, at least, is what's called a duration curve. If I've now selected that discharge we're seeing here, if I then click on the duration curve, right-click on that, and I can run it to a list or to the time series table. But if I run it to a chart, then it'll just plot a duration curve, which then is the one which is down here. Now, we don't really believe that all this data is correct. We probably believe that this period here is, well, at least better, right? So what is the duration curve of that one? What we might do then is that we only select this period. So this is from 53 to 68. So if again I select this time series, then I go over here and say extract time period, and that time period should then be from, say, 1953, November, that's okay. And then 62 we take 1968. But instead of running it, what I do is I add it to a sequence. You can take different tools and put them in a sequence and then run them all at the same time. So I made a sequence where the first is extract time period. Then I go back up to my duration curve and say add to sequence here. And then I take the duration curve and plot it. So that is then to chart, add to sequence. And now if I run the whole thing, then it came down here. I could save it, but I didn't do that. Let me just remove that one, and then I take this one and move it to an existing chart, which is that one. And now we have the two rating curves on the same, I don't know, can you see them? Yeah. So that really changed the duration curve a lot, right?
The flow duration curve.
The flow duration, yeah. So this orange one here at the bottom was then the flow duration only using those initial 13 years instead of the whole series, right? What you would probably do is delete all the data you don't trust and then maybe make duration of the whole thing and so on, right? But like that, you can use tools like this to just look at the data, work with it a bit to see analyze it and so on. Often it's used in conjunction with other tools where you have your basic data. So often, at least the way I work with it is that the basic data is somewhere else, and then I take it here, analyze, make some change, and then in the main database make the changes. But you can also do it directly here. So what we'll do in the afternoon is I've copied some standard exercise from some of my colleagues, which we'll try to go through, which hopefully works also in the version that you'll now get. And then I'll just prepare data for that exercise, which are made on data from this area. So those two we'll do after lunch. Up to lunch, I will then keep talking about something else. Do we need 5 minutes?
No,
Or we just continue?
you can stop any time between 1 and 1:30.
Okay,
Not
okay.
Maybe 1:10, 1:50, that's fine. And then we'll assemble it.
NAM means nedbør afstrømningsmodel, and that's Danish for rainfall runoff model. So very simple. But now I'm going to talk about something more political, you could say, because there's data of many types, and there's also data on conditions on water use. Do we produce the hydropower in our state that we can and that we should? Do we provide water for our people? Are the farmers happy with the irrigation water they're getting, or do we have goals that we haven't reached yet, and so on? I mean, there's also, not least in India, I noticed, there's a lot of politics around water, right? There's also a lot of international attention. In the UN system, for example, the UN is trying to help the development in all countries, particularly those lagging behind. Africa, a lot of very poor countries, for example, also some in Asia, like that. So in the UN system, they have decided on these sustainable development goals that are in many different areas, lots of them dealing with water also. And mainly in Africa, where so many countries are lagging behind, there's a lot of focus on that. There's also aid from different organizations, but there's also internally in the countries a focus on how are we developing? Are we actually meeting our goals? Are we moving forward as we should? And there's been pressure from many sides that information about this should be publicly available. It should not be difficult for newspapers and other for media to get information about how is my country doing compared to other countries. And is my country actually delivering? The president is saying, yes, water to my people, but what's the actual conditions, right? So we have had a project at DHI with many countries, maybe even all countries in Africa, to help them make a system to monitor how are they actually performing on these more political issues. And that's the one I'm going to show you now. And while I'm showing you this, maybe you could think of, would this be possible in India to have all the states publishing the same kind of information to everybody in India? So it's called WASMO, the Water Sector and Sanitation Monitoring System. And the head of states and governments have decided this, that This is to support AMCOF. This is the African Minister Council on Water, to support the AMCOF Secretariat to develop common reporting format, including indicators and guidelines for reporting annual progress to the African Unit Summit on Africa's progress on her water and sanitation targets.
Yes.